rain will be back soon.
Okay, this is the scariest bit of the podcast, making sure that I push record. Yes. Once I get past the technology, I'm all right. So I always get told off for microphone position. So if you can, about 2 fists furthest away. I know. Yeah. It's because if one of us is sitting back here, and one of us is eating the mic,
right.
It can sound very different. And then I stress about sound quality and so on.
Well, no.
So if I can
Good thing to stress about, isn't it?
So well, yeah, we got the studio now. So we used to do everything online on Zoom because I started the podcast during lockdown, which I loved. You know, it gave me a bit of a purpose, something to do.
Yeah, an outlet.
Yeah, it was great.
Yeah,
and I love. Like I say, I'm a curious idiot, especially when it comes to the universe. So I'm excited. This is actually a life ambition, life goal of mine to sit in a room with someone like yourself.
Oh no, we've got to get you some new life goals.
No, I'm serious. The universe. I mean, if you're talking about curiosity, there's nothing bigger than being curious about than the universe. So what I found is through podcasting, listening to podcasts, it's a far more enjoyable topic for me. When it comes to textbooks, even the friendly ones like Neil deGrasse Tyson, I think it's Brian Greene, Brian Cox, Stephen Hawking. They're great, but they make the universe difficult for me to understand and learn. But conversation, I find it fascinating. There's so much to talk about.
And that's it. I mean, it's one of those things where, people do spend years, decades, however long, studying this stuff, and then to think, a paperback or something is gonna, get into all the most interesting stuff right away. I think it's too much to ask. And
it's understanding it for the typical guy like myself who's just interested. Because I was thinking on the way here today, back at school, what they taught us about the planets and the universe, and it went as far as Pluto. Do you remember the old-fashioned model? It was like, here's us, we're all that matters, and then you got these few other planets. Mars.
They've demoted Pluto now. So
yeah, Pluto's not a planet, right? That's even gone. But that was it. That was the end of the universe in our heads, and it's crazy to think that it expands much further beyond. And this is what I can't get my head around, that people have theories that it could be infinite.
Oh, yeah. Absolutely.
But how? I can't even comprehend.
Well,
what does that mean?
Yeah.
Does it actually mean infinite, as in it goes on forever?
It could well do. And that's the thing. We're how do you get your head around infinity? We use tools we've developed, mathematical tools. That's how I get my head around it. It's not like I have a picture in my head of what infinity looks like, because we're just not equipped for that.
Do you push your brain as far as you can in terms of just like logic and understanding, and then you revert to the mathematics to back it up? Like, do you actually sit and ponder what these things are?
Depends on caffeine levels. Very, very, very closely dependent on caffeine levels. Everyone has a different technique for how they do their science, how they understand their science, and it's always a mix. Some problems you sort of come to and you think, I want to understand how big that galaxy is, what it's made of, questions like that, how old it is, how many stars are forming in that galaxy. And if you're experienced with that sort of thing, you'll just know what to try first. You just try some things, see what the numbers look like, and it's like being an experienced fisherman or something, right? You know what bait's put on already. Do that, see what you pull out. Other things are real head scratchers. And they can be these very weighty questions of, is the universe infinite, things like that, or even just really mundane stuff that you sort of need to get past to get to the next bit of what you're really trying to understand. And I think in science as a whole, not just astronomy, there's a lot of that goes on. You have to solve X, Y, Z, A, B, C before you can get to the good stuff. And so I probably spend most of my time not, pondering the mysteries, but debugging some code.
Okay.
Or, I had to drive a computer up the motorway to get it installed in a different site last Friday. That was part of my job. So not much deep thinking was going on then. I had Radio 2 on and was, just listening to whatever was on there. It's a very varied job, really, and so having this opportunity really to sort of take a step back and think about some of the bigger questions is just really nice.
Cool. Well, thanks for coming out. Thanks for coming up. Cheers, by the way. It's great. It's great to meet you.
Thanks for having me.
No, I was doing a bit of research, obviously, through the week. You've studied at Oslo.
Yeah.
Oxford, Manchester. Oslo's a cool place.
I had a lot of fun there.
Yeah.
I'm
Very cool.
really fond of the Norwegians, and the way they relate to nature is really nice. You know.
Yes, you can get past the cost, which
yes.
Once I was there for a day, you just embrace it, don't you? I spent 6 weeks in Iceland as well, and that's
right.
Same thing.
£9 for a beer, that sort of.
But do you know what, fella? I was out in Stratford a few weeks ago, just my local town. That was £6 a beer, and I'm like, well, we're catching. You know, we can rant and rave, but people would come to places like London and think, wow, this is super expensive.
That was, certainly my first experience in
London. Obviously very well travelled. You're a reader of Cosmology.
Yeah.
So that's what you do.
I'm qualified to read. It's one of those university titles, isn't it?
Was it curiosity that got you into the role? Like, did you sit there as a young lad and ponder what the universe was all about, or was it more through the art of just good education as a youngster and following a path that you felt like you should be on because it was a good career?
I think it's a big mix of things. Really, go back to childhood. It was my parents, and particularly my dad, who really encouraged me. And the way they encouraged me wasn't, they didn't send me to space camp over the summer or something like that. The way they encouraged me was, we go to a second-hand shop, and I don't know, there'd be a book about space or something, 20p, whatever it was back then, and the fancy toys or something like that. My parents wouldn't be into that, but 20p for a book about space, no problem. Anytime.
What did your dad do?
He was a civil servant, so he worked for the valuation office, so sort of surveying stuff.
So where did his interests in space come from?
He's really kind of a general knowledge guy, I think. He likes a good pub quiz and stuff like that. He just has a general interest in things. I think in another life he might have been a geographer or something. He's always the first port of call if you need to get somewhere and want to know how to do it. But just more generally, I think he's... And my mum too, they've just had a interest in the world, and they've also... I suppose it's a family thing as well. They've prized education. And so things like having books around, that was always a thing they were big on. And... Oh, my chair is slowly...
I thought you were just shrinking.
No,
So if you like lift your bum up and then press that handle on the right, it will shoot back up.
Oh dear. Right.
See, we can talk about deep shit like the universe, but figuring out how to work these chairs. Yeah. So if you just stand up literally and press the handle, if not, I'll come around and do it. It's happened to a few guests. I don't know why it just collapses. Let me come around and have a play.
So you can have all these fancy university degrees.
I know, mate, but when it comes to fixing a chair, I see what you mean. Are you all right being a midget for the day?
I don't mind.
Or do you want to swap chairs?
Perspective on it. No, don't worry.
Oh, there we go.
Oh,
you're on.
Right. It'll be fun when it happens next time.
There we go. Where were we?
So we were sort of talking about
where
it all...
Bit.
Yeah. Okay. All good? Yeah. Where I got interested in it. So an early memory is my dad waking me up. I must have been 4 years old or something. In my little kid pyjamas, rubbing my eyes, and there was a lunar eclipse.
Yeah.
At like, I don't know, midnight, 1 a.m., something like that. So he dragged me out of bed just to see this lunar eclipse. And they happen every, year or two. They're not the most uncommon thing. But, like, for him to think, oh, Phil would be interested in this, get me out of bed, knowing I might not go back to bed, and it's a rod for his own back, and, taking me out into the garden and having a look at that, I think that's something that's meant a lot, really. I wouldn't have known at the time, of course.
Yeah, of course.
But it's an attitude, isn't it? And so I think a lot of that comes from him and my mum. They bought me a small telescope, like a little Argos one, when I was a few years older. I think one of the first things... Have you ever seen Saturn through a telescope?
No.
Oh, it's the best thing.
Yeah.
You're not prepared for it, right? When you think, oh, it's Saturn, you see all these pictures from the Hubble Space Telescope, or even like computer renderings of it on Star Trek or whatever, and you think, oh yeah, Saturn. But when you look at this, it's like a little gem in the sky. This little yellow thing always looks small through these telescopes. That's the first thing you sort of don't realise. but all the detail you can see, even though it's so small, these little rings. And of course, it's a giant gas planet. It's gigantic, many, many times bigger than the Earth. But you go and see it. You can do this with a big pair of binoculars. Anyone can do it if they can borrow the equipment or something. So if you've never done it, it's nice. It's a nice experience.
Yeah.
No, you could be as cynical as you like, but I think everyone will get a kick out of seeing Saturn for real.
Well, already I can see the passion and enthusiasm that you speak with, and curiosity for me is just the best thing to have. Because I think in our driven world where, culturally it's about success and achievement, we only put our attention on things that we think are going to advance our life or our skills. And I'm like, there's so much fun and education to be had from like just exploring things that, might not necessarily make your life any better or different, but yeah, just knowing and learning and being curious and talking about this kind of subject, it's exciting. Not everything has to be so serious. It's good to learn. I don't think our kids are taught enough of this these days. It's like, I understand, a path in life, but sometimes it's good to have fun and explore.
You have to. You can really try and optimize, right?
Yeah.
You could say, well, I want my kid to be the best accountant ever. They're going to do practice their sums every day, but they'll be missing out on a lot of stuff that, even if they do become an accountant, will be really useful to them. So you just, the world isn't set up in a way that you can just optimize completely. And being a scientist working on, inverted commas, blue skies research, not applied research in industry, but sort of really just asking questions because we can, you sort of see, really how often it really does pan out if you just follow your curiosity. And so you look at all these sort of wonderful inventions of the modern world, I don't know, Wi-Fi, the internet, can name a few more. A lot of those came from blue skies research.
Sure.
They weren't, there wasn't someone in the lab trying, I am going to make Wi-Fi. They were just solving another problem that they needed to, measure something with a radio telescope.
Yeah.
And we're human, right? We don't know everything. So much of what we learn about the universe comes as a surprise, and so if you go and look for those surprises, it's just super useful as well. So
But that's the fun, isn't it, in this element
Absolutely.
of surprise, like the element of unknown. So let's take accountancy forever. By the way, not slagging off accountants.
no, me neither.
I love my accountant. He's one of
very
my best friends.
necessary.
Yeah, absolutely. But you kind of like know that you're going to go to your place of work, and you'll do your job great, and then you might not learn anything particularly new or interesting. With the universe, you never know what the fuck's going to happen, what you're going to learn. You don't know a lot of the answers. For me, that's where the fun is. It's in that unknown piece. It's like, can I go to work today and learn something new, discover something new? Expand my knowledge. It's like, there's excitement, there's opportunity. And yeah, for me, that's great. Even this conversation now, like, I know for a fact I'm going to learn a lot.
Well, I think I am too, right?
Mate, I don't know if there's much I can
think
teach you. I can teach you how to do the chair. That's one thing.
Oh, well, I'm in desperate need of that.
If you want to talk calories, proteins, macros, carbs, fats, weightlifting.
I'm at your...
No, let's talk
mercy.
about the universe. It's way more interesting. So when we look at questions like, is the universe infinite? Do you think you'll ever discover an answer in your lifetime? And two, is it more just of a fun question for you to explore rather than an important one?
So, bit of both. So, it's one of those questions where there are certain questions we know we'll never know the answer to, and that's one of them, really. Barring some, shocking discovery, some aliens have written it on an obelisk or something, and would you trust them anyway?
Mm-hmm.
It's one of those things we know we can never sort of directly see with our own eyes, with however fancy a telescope you make, just because of the way the universe works. And a really fundamental thing about the universe is most of the things we see are with light. Light travels at the speed of light, a finite speed, so you can only see stuff as far away as light has had time to travel from it. So if you imagine something that's, infinity away from us, it's going to take an infinite amount of time for that light to get there, and we're not going to be around for that long. So there's certain things where we know we're never going to directly experience what it means for the universe to be infinite. But can we make models of the universe, construct mathematical models of the universe where, they explain all the other stuff that's going on in the universe, and as an implication of that model, the universe has to be infinite. And that's a sort of difficult thing. People are always a bit reluctant to believe predictions of a model like that, but it's something that happens a lot in cosmology. We see the universe is this old, it's expanding this fast, stuff like that. Those are all facts we can observe directly, and we can build a mathematical model. We normally use Einstein's general relativity to build those models, and so that model fits our data, great, but it also predicts other things. Some of those predictions we can test directly, some of them we can't, like if the universe is infinite. And so with that particular question, I think the answer is, how much do you trust the models we're making? And at this stage, I trust them like 80%, that's pretty good.
Okay.
But that's where the answer lies, unfortunately. We'll never have a direct view of that question.
And knowing that you'll never have a direct answer, why do you still pursue it? Is it purely for your own personal interest and enjoyment, or is there excitement in working on something that does not have an end game?
I mean, the thing is, there's so much other stuff going on around that one question as well. There's certain questions we know, they're not really out of bounds, but, we just know the universe limits us. We live in this universe. Wouldn't it be great to be able to teleport to the next galaxy or something like that? We don't think that's really possible in the universe we live in. Going back to Star Trek, unfortunately, some of the stuff in Star Trek won't ever work. But you start thinking about it, and you start trying to answer the question of, well, why doesn't it work? Could it work? What if this happened? What if this happened? And you can come up with some really, I would argue, more interesting things. A bit more prosaic. It maybe takes a little bit more head scratching to really understand what's going on. But by asking questions and not getting answers, you still bring up many, many more questions that the next generation will be able to go and try and answer, and maybe find out something useful, develop a new technology, or find out that it's impossible and can't be done. But it's just this constant churn of sort of human, really creative activity. Okay, you're always trying to come up with a new idea to solve a problem. If you can show that the problem is or isn't solvable, whatever the answer is, that's significant.
Yeah. And
so that's exciting because, every day's a school day.
Exactly that. Exactly that. I think that's exactly where the joy is. What do you think, more people don't pay an interest in what's out there in the universe? Do you think it might be the fact that we don't think it really affects us? How much of it is wrapped up in fear? Because there's some things I've discovered that actually trigger some fear. Extraterrestrial life, the universe being infinite. That is a scary concept. It's one that my human brain, or if any human brain, can get their heads around. There's a lot of fear in the unknown, and the universe has tons of it. So even the example you gave of the binoculars at Saturn, I'm like, that sounds fucking awesome. Why aren't people interested?
So I think the thing is, really, on the whole, we're quite lucky in this country that there is the general public does have a pretty good level of interest in astronomy. That's not the case everywhere. I think part of that comes from, can you see the night sky? Is it something you ever experience, really? And as we start living more and more in cities with bright lights and smoke or smog in some countries and things like that, how often do you see the stars to be able to trigger that thought of, oh, I wonder what's up there? Now, as well as that, we have things like social media and just the regular media who actually do a reasonably good job of reporting on, the next amazing discovery from the Hubble Space Telescope. Or, I remember on Christmas Eve this year, I watched the James Webb Space Telescope launch. That was on, the news, essentially. Not just a 24-hour news channel at 3 a.m. I watched it live. People are interested enough that this completely esoteric thing that, you're right, mostly space stuff doesn't affect our day-to-day life. They're still interested enough to, think it's worth putting on national TV, or, the BBC funds Brian Cox to do a landmark series on the planets or things like that. So I'm actually quite optimistic about the general public's attitude to this stuff. I think people are interested. do they have the opportunity to develop a deeper interest, though? That's the question. How do you do that?
I would say with a bit of a conflict to what we're saying, with social media you have a huge opportunity now. So like through the art of podcasting, listening to podcasts, I've educated myself on a variety of different subjects. So I think opportunity isn't going to slap you around the face.
No,
I think
no.
you have to go and look, because you can learn a lot these days.
Mhm.
But why would you if Love Island's on? That's where I'm probably a little bit more cynical than yourself, and think like it just for me demands a bit more attention. I mean, there's all sorts of UFO sightings going on, and I'm like, why isn't this front page news, man? This is insane. Like, if we really don't know who these UFOs belong to, then that is fascinating. That is fascinating. I'm like, why aren't we talking about this? Is it because we just don't know? Is it too scary? Is it because we don't have answers? Is it, I don't know. Like, why aren't we going there? Why aren't we? Because it's bigger picture for me. That's why with everything that's going on in the world, it seems so insignificant when there's a bigger picture out there.
I think there's a lot of other stuff going on in the world as well, right? Natural disasters,
Loads.
the war in Ukraine, stuff like that. And if you were able to focus on important stuff like that all the time, you wouldn't sleep. I mean, you really wouldn't sleep.
But that's the news, Phil. That's the news. That's why I haven't watched the news for a long time, for years, because it is just that kind of information. And that's where I kind of got a little bit of respite in the art of like the universe and stuff. It's refreshing to think outside of our tiny little world that we've made for ourselves. Because I think we do kind of like, I think we're guilty of thinking that we are the center of the universe. We individuals are the center of the earth, and we are all that matters. And I think if you can this is the difficulty. I think if you can understand how insignificant you are, that helps a lot of your life decisions, because they're probably not as big as you think. But there is a flip to that where you could become total nihilist, where you go, none of this shit matters, man. Like, I'm this little ant on this planet, like, and nothing I really do does matter in the grand scheme of things. So it's knowing how to balance that out when you educate yourself on the bigger picture. But you obviously have to take some personal responsibility for what you do and create your own good life, right?
Well, I think when it comes to things like meaning and what does it mean, for us to be alive here and now, like, do we matter? Don't we matter? Yeah, of course the universe is this giant thing. It's very impersonal. It, by and large, doesn't care that we exist, but also we're part of it. It made us. There's this whole story going back almost 14 billion years of how, I'm just looking at my hand right now, the amount of amazing sort of accidents and physical processes and things that had to have happened for my hand to be here right now is just mind-boggling. So, I mean, the hydrogen in the water in my hand came from the Big Bang itself. A lot of the carbon and oxygen that's in my bones and my blood and stuff like that came from a previous generation of stars that died and exploded in supernovae. I mean, I'm just sitting here now. I'm this sort of amazing evidence of the history of the whole universe, and all of us are. And so, if you think about things in that way, we sort of do matter, right? Because we're part of this much bigger whole. I wish I knew why this much bigger whole was here, why there's a universe in the first place. But in terms of getting nihilistic or things like that, I don't think we have any right to be nihilistic, because it's just such an amazing surprise that we're even here. Surely instead of nihilism, it just makes a bit more sense to just be amazed that any of this worked at all. And here we are arguing about Love Island or something.
Yeah, but I think that's the great thing about educating yourself on the universe. You realise, wow, like, this is pretty special. Maybe I should do something with my life or make the most of it. Because fear, for me, of course, it's primal, it's in us. But when you educate yourself on the importance of the bigger things in life, like, the smaller decisions don't seem to matter as much. So there's things that I was fearful of 5 years ago that I'm not fearful of anymore. One, they're not real, and two, I've moved past them. And some of that has been through nothing other than educating myself on physiology, so knowing what's actually happening in my body. Because if you don't know what's happening, you're like, why do I feel like this?
Yeah.
Am I the only one that feels like this? You soon realise that you're not, and it's a normal thing. But yeah, it's like, okay, I'm pretty insignificant, but I'm pretty special to be here. How can I make the most out of this? Because it is a holiday, right?
Yeah, and it's a personal thing as well. It's about you on some level. I mean, we just talked about being our own center of the universe. We can't be just us in the universe. Right? We're not alone in the universe. We're on this weird rocky spaceship we call planet Earth. That we're all sitting on this. We all need each other to be able to do things like not pollute the atmosphere, so we can all breathe. We all rely on each other. So even if you are your main focus, even if you do feel that you're the center of your own universe, or it's somehow helpful to prioritize yourself, you still have this tremendous reliance on other people, other things, and so you need to look after them too. So I think it's easy to not make that link, that prioritizing yourself and your own needs, which is often a very good thing to do for your own health, your own mental health. Giving yourself time, not spending all the time on work or Love Island or something instead. Prioritizing yourself doesn't mean completely deprioritizing everything else.
No, of course.
And that's the wonderful thing, I think, about the world we live in, that everything is linked and connected in some way or another. Yes. So we can't ignore everything else.
Which makes it so upsetting when you have horrible things going on in the world, like what's happening now in Russia and Ukraine. Because, if you see that connection, you realise it's the biggest waste of energy everywhere. And everything is a paradox. I do, like, something I teach my guys is always about the importance of self-love, self-care, self-respect. Sounds a bit cheesy and cliche, but it's true. Like, you get your own shit in order first, so that you can be this decent person to be around, who can then hopefully help the people within the four walls of your home, your family. And then if you're lucky enough and you can expand beyond that, you can make a difference to your community, and we can do podcasts and reach more people. And it's a really cool game to get involved in, because you find, like I say, you do the work on yourself, and all of a sudden I'm impacting other people. And that's the key, I think, for any guy who's on a mission, on a purpose. It has to have some relevance to other people. It can't be totally selfish.
I think also that there's some element of, if you get the fundamentals right, if you get the basics right, a lot of, like you were saying, a lot of the small things will actually look after themselves. Absolutely. A lot of those small worries will actually dissolve or not be as big a deal as you thought. Just being able to find a place where you do have that stable foundation, where you can sort of not have to spend all your time worrying about X, Y, and Z. It's a luxury in some ways. Not everyone can get themselves to a place like that. It's very hard out there right now. I mean, especially with the cost of living, what it is, and stuff like that. Having that time to look after your health and stuff like that may not be as easy to come by as you'd hope.
Yeah.
So helping other people to come to that place, I think, is a responsibility everyone has. Helping out other people just a little bit really helps the whole system. It helps all of us, and does give us that time to go on and do, the most interesting things we're interested in.
Absolutely, yeah. Nothing makes you feel more valued than offering value to people. It's what makes, I believe, what fulfills you and makes you feel happy and like a good person. Even if it's, again, we're not talking about changing the world, but even if you're a good son or a good father, husband, whatever it is, it's an important role. How much time do you spend thinking about your purpose and your life versus just waking up each day and going to work and getting things done?
So it depends on the season, really. Sometimes things happen in your professional life that do give you a bit of, I don't know, existential angst. And they're normally career things or maybe things that happen in your personal life. So if a relative passes away or something like that, I think most people are prone to a bit of self-reflection. What I had recently instead was we've had lots of strikes in the university sector, and there's been lots of arguments about the pension cuts and stuff like that, and they're quite bad. We're looking at people being much worse off than they have been. We have a lot of younger people coming into the field, not having such stable employment conditions, people who have to take 3 jobs just to be able to teach enough to make ends meet, and so going on strike and taking part in that sort of thing got me reflecting on is if this is the way it's all going, do I want to be here? Should I get a job at a tech company or something like that instead? You know, is this where I still want to be? Is this offering me and my family the stability I want? Am I going to be happy, or am I going to be spending less time thinking about the universe and more time thinking about a second job or stuff like that? And of course that's not just in my field or in universities. That happened to a lot of people during the pandemic as well. I think that there was a, you know, when you mentioned yourself, you know, sitting at home and, you know, doing whatever you're doing while we're all trapped inside. What is this what you want to be doing? Is the work you have meaningful? Even is the house you live in the sort of environment you want for yourself? So I think to answer your question, it sort of depends on lots of external factors. How much time I spend thinking about my existence and whether I'm doing the right things to further my goals. And your goals change, of course, as well. So I've just come out the other side of a big existential puzzle. I've recently moved to a different university. I'm now at the University of Manchester, and I'm you know, trying that out. The research I'm doing is on similar topics, but you know, it's been quite refreshing to sort of have a new start.
Yeah.
Kind of thing.
Isn't that the way that all courageous change occurs? Through going through some form of existential angst, some form of adversity, some form of rock bottom where something really is not going the way that you want it to go, and therefore forces you to question your existence, your next move. Why am I here? What should I do next? I think we all need a bit of that pressure.
It definitely gives you a kick up the bum, right?
I think so. I mean,
necessity is the mother of invention, right?
If
you're sitting there and, you know, on a Friday night and thinking, I'm just fed up. There's a couple of ways that could go. You could either just continue being fed up, or you can say, well, something's got to change, and then maybe develop that, like you were saying, this courage in yourself to give it a go. Can take a few tries, though.
Well, yeah, I mean, I'm sure you've done some incredible work, but if you could discover how to move men faster along that pipeline, that would, you'd be a very, very, very rich man, because it's always it's always at the bottom end of that pipeline where things are very bad or desperate, or to the point where, like, we're talking strikes, we're going to slash pensions. Oh shit, what am I going to do?
Yeah.
It's always in that zone. I know from my own experience, that's what's forced change upon me. Being so miserable and so unhappy that I can no longer continue. But just being a little bit miserable is okay. That's quite comfortable.
I mean, you know, having ups and downs is normal. It's good for you. It's good for you. I'm very suspicious of people who are happy all day, every day. That's there must be something in their drinking water if that's what's going on. And you know, you do have some positive thoughts and positive developments that can come out of negative periods of your life. It can help you reevaluate what's important, and that's ultimately a positive thing. It's sort of like how wildfires can sort of renew the forest. It's that sort of thing, isn't it?
Yeah, and I think if you really reflect, that's more common than not. So the best times of your life, especially like if you think about career, it's the easiest one to take. Like, you study hard for 3 to 5 years to get into the good role that you want to be in, and then when you get in that role, you continue to work your ass off. So it's like behind that success is sacrifice, discipline, challenge. So when we're searching for a better life, we should always be searching for a little bit of discomfort, because that's the way we get it. And learning is uncomfortable. That's why a lot of people don't do it. It's much easier to just continue doing what you know. Especially on the topic of the universe, it's hugely uncomfortable to learn, which is why I think I'm drawn to it, because there's so many uncomfortable questions, and even the thought of like extraterrestrial life, like that will send shivers down some people's spines. For some, it will excite them. I'm sat in the middle. I'm like, what would extraterrestrial life look like? Would they be here to help us and look after us, or would they want to destroy us? Like, what would it look like, and how real? Could we wake up one day and there are aliens everywhere? People will think I'm nuts, but I don't think that's on the side of impossible.
No, it's not really. It's one of those things where there's like the Hollywood version and the real version. Okay. So do I think there's life out there? I think it's overwhelmingly likely there's something that we would call life out there, because we developed through evolution and a series of, over many, many billions of years, sort of random, almost chemical reaction accidents and happenstance and stuff like that. I think it's not clear if there was some level of inevitability about it, that, okay, if the first cell wasn't formed then, it would have been formed this other time instead.
Sure.
We're still looking at places like Mars. We now know, this is new over the last 20 or so years, we now know that there was water on Mars, and there's ice water on Mars as well. So could Mars have harbored life? It's possible. We're sending probes up there. NASA, ESA, the space agencies are sending little rovers up there to drill samples from the surface. Eventually they'll return some samples to Earth using a very complicated series of it involves helicopters now. I mean,
Cool.
Mars, little dinky Mars helicopter drones, all super cool engineering stuff. But another thing's happening at the moment as well, which is we're developing space telescopes that will be sensitive enough to. So again, something that's happened in the last 30 or so years, we've discovered that there are planets around other stars.
Which changed the game, right?
We knew there should be.
Yes.
But before, let's say the early 90s, we didn't know of any specifically. So you think there's always that little niggling feeling at the back of your head, like, could we be the only solar system? Is there something that super special about us? And actually, there's not.
And these are Earth-like planets, right?
Some of them are. So the vast majority we see are more like Jupiter.
Okay.
Jupiter's really big. It's really bright. It's just made of gas. In some ways, it's a easier planet to form than the Earth.
Okay.
So the Earth is kind of shrapnel that formed from all the spinning debris from planets like Jupiter forming. So you can ask, is it typical to get Earth-like planets around any star? And at the moment we think it's not uncommon.
Okay.
We think there should be quite a few Earth-like planets out there.
When we say a few or some, do we have numbers?
As a fraction. So in the Milky Way, our galaxy, there's a few 100 billion stars.
And then around those stars...
Around those, you might typically expect to have at least one planet around each star, but most likely more.
Wow.
So, we've got... If we're looking for a planet that's very much like Earth, we've got a few 100 billion rolls of the dice.
Few 100 billion.
Yes.
So by the art of probability, isn't it near impossible not to have some form of other life out there?
So this is our feeling, this is our reckoning, but we're also in a place where we might be multiplying a very, very, very big number by a very, very tiny probability. What are the odds that some form of, let's say, bacterial life forms on any planet? Because that's a bit easier to form than, ape-like creatures like ourselves. What are the odds of that forming? Is it 1 in 10? Is it 1 in a million? Is it... And so that's a number we'd really like to know. And people actually do lab experiments. They take some sort of mix of quite noxious gases, ammonia and stuff like that model the way the early Earth's atmosphere might have looked like, and they zap it with lightning, and see if they do get complicated, organic compounds forming that are the building blocks of life. Spoiler, they do. So it seems like forming the building blocks is pretty possible. That's not so rare as long as you've got the right mix of gases. But the many, many, many steps taking those, that sort of chemical gloop and turning it into people who can communicate via radio and stuff like that. I mean, we've only developed that ability in the last 100+ years.
Yeah, but that's evolution as we know it, right? Like, that's not to say it's the only way that evolution can occur.
No,
is that
absolutely.
true?
So we do think there are certain things that make it much more likely to develop life than not. An abundance of water is a really good one. Having carbon on hand, lots of carbon. So you can imagine we call ourselves carbon-based life forms because a lot of the chemistry in our body happens using carbon-related molecules. But you can also imagine using silicon or some other element like that. It just doesn't work as well. So again, back to Star Trek, you see these silicon-based life forms on there or something. That's probably less likely. But there's a lot of carbon, a lot of oxygen, a lot of hydrogen in the universe. We think there's a lot of water out there, and even in space, we can detect the sort of weak, very faint emission from certain molecules that have formed spontaneously out there in space. And we do see things like ammonia, methane, other things that are a useful input to life. We also see alcohol, certain like methanol and stuff like that,
Wow.
has formed spontaneously in space. I don't mean in a vodka bottle or anything, just tiny trace amounts.
That
of
would be cool.
But our universe seems capable of making the complicated molecules that are needed to then make more complicated things like bacteria, which are then needed to make things like us.
What do you think, if you could just kind of like scrap the evidence to the side for a second, like do you have a personal opinion that there is advanced life form out there?
I think that's very likely, again, just based on really this almost philosophical thought that we shouldn't be that special, surely. We shouldn't, this gigantic, vast universe, we shouldn't be the only things that can, reason or, use tools or whatever you want to reduce humanity's vital characteristics to being. So I think there is other stuff out there. Now then the question is, that's the kind of universe we live in, one where other things like ourselves should exist. It's also the universe we live in that has this speed limit, the speed of light. It's also this universe that's incredibly vast. So in terms of those beings being able to travel and visit us and abduct Elvis or something, I mean, I'm sure they'd have bigger fish to fry. That seems much more difficult. So no matter how advanced your technology is, there are still some basic limitations of physics that you have to overcome. And a really important one is, how much energy does it take to get from A to B?
Okay.
And the amount of energy it takes to get from us, of things of our size, to get from our solar system to the nearest solar system, about 4 light years away, is tremendous. You'd have to think that whatever civilization you're talking about has just really a lot of energy to spare. I'm saying energy, that converts to things like money, resources, stuff like that. But they must have such tremendous resources that they're willing to, send a few little grey men. And it may be that somewhere in the universe they've developed the technology and the ability to do that. But it means sending your relatives in sort of some kind of cryo sleep or something on a journey that will take at least tens of years, even with the most advanced technology, because the laws of physics prevent you going any faster than that, really. And so it's such a overwhelmingly difficult endeavor that I think if those beings were able to visit Earth, they'd be a bit more excited about it and would land on the White House lawn.
When we were talking like the law of physics, do you ever challenge that statement, as in the law of physics? Because with these UFOs that are being sighted, they're talking about the way that they move and the propulsion behind them, and it challenges physics. Do you ever feel like that could be possible, where there's other rules that you could play by, such as time travel, portals, stuff like that? Does that ever, like, just for fun, come into your mind, where you think, actually, we could be accessed by extraterrestrial life anytime?
Absolutely. I mean, for some of my colleagues, it's the whole game. There's people out there, particularly theoretical physicists, who the constant challenge, the constant game is trying to push ever further into those murky corners of reality to
crazy
figure out
people.
what's possible. We're all crazy, of course.
I like those people.
But they're really trying to push to see what's possible, and so you do have people, some of whom end up as visionaries, right? Your Einsteins, your Stephen Hawkings, people like that, who have these absolutely wonderful ideas about these completely exotic objects. I mean, black holes. Who started thinking about those? They're just the most extreme physical phenomena you can think of, and yet people have spent years, decades of their professional life trying to figure out the implications of, well, what if we did have a black hole here? What would happen? And the sort of exciting thing about physics is, as a field, is it's not just imagining things, it's imagining things with rules that allow you to understand whether it's real or not. And so there's certain things out there that we haven't seen yet, which are absolutely, to us on Earth, are just totally bizarre. If you ever saw one in real life, you'd be like, wow. I mean, 10 Niagara Falls worth of amazing, 1 million maybe.
Yeah.
And we know that they could exist for real. And then there's other things that we know can't exist for real because of what the implications of that would be.
Such as?
So,
can I just ask you to move forward a tiny bit? Sorry. Yeah, such as? What would you define as, like, can't be real?
So we know, again, back to the speed of light being the speed limit of the universe, just instantaneously traveling from one bit of the universe to another, it just can't be done. If it could be done, there's certain experiments that you can do that you know, not using people, of course, but using fundamental particles. You can test to see if that sort of thing is possible with fundamental particles, or at least if you can't teleport one particle to another place, like at least the initial stages of doing something like teleportation, you can try it out and then see, you know, does the universe allow this? And we've done that. People have, you know, very smart people building amazing experiments in basements around the world have tried this out, and so they found out that no, you can't just instantaneously teleport something, but you can teleport things. It's just not instant.
Is there not a yet that should be added on to any? Because I'm always cautious when we always say it can't be done, because surely there's things if we backtrack where we've said, you know, yeah, it just can't be done, can't happen. The universe can't be infinite, and whatever it is, and then we prove ourselves wrong. But isn't that what science is all about, right? Trying to debunk some of these myths. Or challenge some of these theories, rather.
And you know, you're constantly trying to do that.
Yes.
Because if you're the guy who proves Einstein wrong, you get a Nobel Prize, you're famous, you know, all the money or something, I don't know. You know, there's a motivation there that we're incentivized. So sometimes I'll use climate deniers as an example because I think people are more familiar with them, that they can do things like there's a bit of conspiracy theorizing where they're saying, oh, the scientists are covering up what the real situation is. That is not the mentality of any scientists I know. We can be quite bitchy. We're all trying to prove each other wrong, because that's where a lot of the, in the nicest way possible normally, but some people have real beef. Yeah. Some people won't talk to one another.
Wow.
You know, years of professional acrimony
Over
really get to them. Honestly.
Yeah,
so
it's common, right? Religion's a great example.
And, you know, we're all just human as well. So, you know, you as a scientist are generally motivated to try and prove the other guy wrong. Not always, but generally. And so a lot of work goes into that. A lot of funding, in fact, goes into that. I'm not saying 100% of it, but a pretty sizable amount of the investigative work scientists do is trying to test things that we think are probably true anyway. One of those things is general relativity, Einstein's theory. I've worked personally on quite a lot of projects and even 1 or 2 space missions to try and test general relativity, because if you show that actually there's this tiny situation that we've never seen before where it breaks down, all of a sudden you've got a handle. You've got a handle on how the universe really is. It's like a thread you can start pulling then. So a lot of theoretical work in science is about just trying to find a thread to pull in the first place. And I think, you know, 300 years ago when you had gentlemen scientists who were, you know, wealthy people, landowners who'd sit at home and ponder the universe, there were a lot more threads to pull back then than there are now. Science has really grown into this giant endeavor where we have tested a lot of stuff already. It's very annoying when you're a student. You think, I've had this great idea, I'm going to test this thing, it's going to be a really interesting thing, and then you discover in the Soviet Journal of Sciences 1967 that someone did it already. and you know, that's a bit disappointing, but also kind of good that you know, there's a lot of aggregated curiosity out there.
Do you have to be careful that you don't fall in love with your ideas and beliefs and then work so hard to prove yourself right versus trying to get to the truth?
Absolutely. And you know, people do fall into that trap. People do, you want to give, if you've got a new idea at the start, it's not necessarily going to be easily accepted. So you want to give it a good chance. You want to give it a chance, even if it's the idea itself isn't fully formed. It's got some rough edges that need ironing out. You can't fix all of that instantaneously. you need to give it a bit of breathing space to develop and mature, and maybe those problems to be solved. But eventually, you've got to know when to quit. And sometimes, that idea makes its way through the adversity that's thrown at it, and becomes stronger as a result. You develop the idea. You make it closer to the way the world really is. That's happened a lot in particle physics, for example. Lots of weird ideas about what fundamental particles are and what they're made up of. A lot of that was happening in the 50s, 60s. And only a few of those have stuck around. And the reason they've stuck around is someone went out there, built the Large Hadron Collider and things like it, and tested it. And all the other stuff, people knew when to quit. The data said, no, this thing doesn't work, this idea doesn't work. But yeah, you certainly get people who cling for too long on, and it's hard to know. It's hard to know when to stop. Your baby. It's your baby, right? You've spent years working on it. It's hard to know when to leave it to one side.
You're right. That's one of the most difficult skills, or maybe it's not a skill. I'm not sure. And you can go by gut, maybe. I don't know. But knowing when to quit on anything in life, because you don't know how far away you are. One, you could be delusional, which is
absolutely, yeah.
Yeah, again, you have to do some real good work on yourself to know whether you're delusional or not. And a lot of us are. I've been delusional many times in my life, and you learn the hard way.
I'm a Stoke City fan.
So well, then you know all about delusion.
Yeah.
Well, I'm a Coventry City fan. I can't say.
Okay.
I can't say it. I think you win that one. But yeah, knowing when to quit, because sometimes you're close to achieving what you want to achieve, or sometimes it's not the right time to quit. Yeah, that's something that I can't articulate or teach or learn yet. I don't think you'll ever know is the answer.
You can't. If you already knew, you'd probably be further along with the problem as well, right? So
possibly, or further down a rabbit hole that's got no decent ending. That's the thing. There's a great book called 4,000 Weeks by Oliver Burkeman. Really, really interesting about. There's our 80 years of life, 4,000 weeks, the average. It's like, you're going to miss out on a lot, accept it. Most of life is about what doors can you shut and be okay with that, because you can't do everything in life. You can't learn everything. You can't be everywhere.
Managing regrets, and, we've all got them, of course.
We have.
I know that's another cliched thing to say, but...
Yeah. Well, you meet the odd person that comes across that, no regrets, don't regret anything. I'm like, bullshit. We've all got regrets, surely. So, you mentioned the word black hole.
I've got to.
You've got
to.
It's
my sworn duty.
Absolutely.
They're super cool.
They are super cool. Do you want to explain a little bit about what a black hole is and ultimately why it's so super cool?
Totally. So what we're talking about, so first of all, you have a picture in your head of a black hole, maybe you've seen it on TV or something. A black hole is kind of this big, typically big object that's formed through a very violent process. Normally, we're talking about something that's essentially almost a sort of a puncture, almost a hole in space and time itself. Now, when I say things like that, it just sounds like blah blah blah, like something from a sci-fi thing. What do those words really mean? So we have our own experience of space and time, right? We can walk through, or drive through, or fly through space. Depending on how long your flight is, you might feel time going faster or slower. Everything in the universe sort of has that experience too. And for the most part, it's like our everyday experience. Time marches on at a constant pace. You're going forward through space faster or slower, but generally everything looks the same. You look out the car window, everything looks the same, but going by a bit faster. Once you start getting really, really fast, you travel through space very, very fast. Space and time start distorting a bit around you. You start seeing everything else around you going slower because you are going so fast. This is something that comes out of relativity. I'll spare you all of the gory mathematical details, but essentially, if you're traveling faster than your surroundings, you're aging slower. All sorts of weird. And again, this is something we can test. We've sent atomic clocks on planes flying very fast, and left another one on the ground, and seen those atoms sort of aged a bit slower than the others apparently. What a black hole is essentially the culmination of all of that weirdness into one very extreme object. So as you get closer and closer to this black hole, weird things start happening to space and time itself. You start getting stretched. I think the term Stephen Hawking used to describe this was spaghettification. And it's sort of like the black hole has a sort of tidal pull on you that can shred you into spaghetti, because the force of gravity is so much stronger on your feet than on your head, for example, as you go into it. But the main thing about a black hole is once you've sort of gone inside this region we call the event horizon, you're trapped in there forever. There's no amount of effort, no amount of energy, no amount of... You could run at the speed of light, you still wouldn't get out of that black hole. So inside a black hole is almost like a separate universe. You're cut off from the rest of our universe. So those things are just absolutely weird. Like, what does it mean? Like, being stuck in this, almost like this cave forever. We don't even know exactly what it would look like inside a black hole. You can make predictions, of course, but we can never go in. We can't dangle a camera in. The signals from the camera wouldn't come out, so we can never know. There's this thing, back to what we were discussing earlier, we have these objects in the universe that we know we can never know exactly what's inside them. We can just predict. And so you have these black holes not just as these weird sci-fi things that are only in the movies. They're real. Almost every galaxy has one, and our own galaxy probably has many smaller ones as well. They're out there, these absolutely bizarre things that are just almost like these kind of pinched off separate universes that material is constantly falling into. Hopefully not people or animals or anything, but, you know, rocks and you know, real physical objects are trapped in those things forever, and God knows what's happened to them. Isn't that weird?
It's fucked up.
I mean,
this is where my brain gets
you
fried.
wouldn't wish it on your worst enemy, surely. Being trapped forever in this thing. I mean,
But, and we don't know
you
what. So whatever
inside.
gets absorbed into a black hole never comes out. Do we know what potential it's got to swallow up things? Like, could it swallow up a planet?
Oh, absolutely. So there's a black hole at the center of our own galaxy. So don't worry, that's about 24,000 light years away. That's a very long time. Even if you're trying, it would take you a long time to get there. This thing's gigantic. It's many millions of times more massive than the sun. But because it's a black hole, it's where space and time have been compressed and compacted into this very extreme state. It's not millions of times bigger than the sun. It's actually probably similar size or so. So it's just in the middle of our own galaxy. You've got this really massive thing in a tiny area. Only stuff that gets very close to that tiny area will get pulled in. Even if you were looking at it from, you know, let's say the distance of Earth to the sun or something like that, I don't think you'd have any trouble getting away from it again.
Okay. So
These
is it
things aren't
gravity?
Sucking. It's all gravity.
It's all gravity.
And just gravity.
But just a stronger...
So much gravity.
So do you think what gets sucked into a black hole is destroyed, or do you think it's gone somewhere?
So that's actually a discussion that's been exercising and causing lots of strife in the theoretical physics community for the last 10 years or so. That's really a very big question. When stuff falls into a black hole, that stuff carries something of the universe with it too. You know, imagine a history book being put into a black hole, right? That history book has literally a written record of something that happened in the universe. It's sort of the same for every bit of dirt, speck of dust, something like that. Anything you put in there carries some kind of information about the rest of the universe. And so the fundamental question there is that information lost? Does the universe sort of lose some of its memory? You know, if I put my birth certificate in a black hole, I mean, I know it doesn't mean I was never born, but, you know, what's happened to that information? Because we can't get it out again. And so what some theoretical physicists think is just within the black hole there's something they call a firewall, which is this very extreme phenomenon where essentially everything that goes in there is destroyed, and the information associated with that is just completely scrambled. And so the black hole isn't full of information that's been taken from the rest of the universe. It just sort of it's turned to ashes almost. Others don't think that. We know that black holes do give off a little bit of radiation. This is something Stephen Hawking and collaborators worked out. It's called Hawking radiation. So if you have a black hole sitting there, it's not like you can see inside the black hole, not at all. It's definitely a one-way mirror, but like little bits of radiation can come off it. The question is, do those bits of radiation tell you anything about what's in the black hole, or are they just completely scrambled? And that's what this firewall stuff is about. Black holes aren't completely black. They almost are. The stuff that's coming off them, does that tell you anything about what's inside or not? And we don't know.
What side of the fence do you sit on?
I honestly don't know. It's one of those things where if we had a really good theory that tells us what happens inside a black hole, we could predict, but we don't. And this gets us onto things like string theory. String theory, one of the main motivations of string theory is to try and explain what happens right there in the center of a black hole in what we call a singularity. We still don't know.
It's more fun to think that information is trapped in there, because if everything's destroyed, that's the end, right, of that conversation, that research.
And it's gone.
Yeah,
There's
it's
no
gone.
way back. It's physically impossible.
Sure, but if information is stored and trapped in there, then that's just mind-blowing.
You can imagine, maybe some way of extracting that information with an advanced technology. Now, we think that's probably not possible.
So when we talk about infinite universes, is this another way that it could be infinite in the fact that black holes contain other universes? Therefore, it's not just what we see. It could be, other, when we say dimensions, perhaps, it's like inside of that black hole because it's like the Big Bang Theory. Like, is it possible that there was more than one Big Bang, and there's, across the universe, there's been multiple Big Bangs that have created other parts of the universe, and we're just one of many Big Bangs?
And that's absolutely possible, and it's something that, this isn't a sort of niche opinion amongst cosmologists. It's the mainstream opinion is, the thing we call the Big Bang wasn't this sort of singular event that only ever happened once. We think probably this thing that existed, just before the thing we call the Big Bang, lots of smaller Big Bangs may have been going off within whatever that is. The theory we use to describe this is called inflation, because the universe inflates really fast when it's first formed. It solves a lot of problems. We make observations about how curved our universe is. When we measure really long distances, is it like being on the surface of the Earth, where if you kept going, you'd eventually look back round on yourself, or is it infinite and like a big flat plane, and you keep going in one direction and you go in that direction forever? That's a question we can answer, or at least get a pretty good partial answer to, by measuring stuff that's really distant from us in the universe, measuring angles and stuff like that. In the same way that a ship going over the horizon tells you, the Earth is round, it's close to spherical. You could imagine being able to make similar sorts of observations, and so we try and do that, and it looks pretty flat, which is why we think it could be infinite. It could go out forever, and this theory we have, this inflation theory, gives us a mathematical model to explain exactly how all that would work.
Yes.
And we seem to need it. We can't explain everything we've observed without something that causes a very, very, very rapid period of expansion very early in the universe's history. Whether you want to think of that as like a Big Bang, like an explosion, or something a bit more complicated where there are many Big Bangs going on, that question is open. And what kind of universe does that generate? An infinite one, a finite one that's closed, like, going around the surface of the Earth, or one that goes on forever? That's very difficult to measure. We hold out some hope we might be able to make a few more measurements that give us a bit more information about that, but eventually I think we'll top out and not be able to answer any more questions about the size and shape of the universe.
Yeah, and we don't know what occurred before the Big Bang, right? We're assuming that is the start, but that might not be a true statement too.
So you can certainly, again, construct these mathematical models that all sorts of weird and wonderful things happen before the Big Bang. You can have ones where essentially there was no beginning to the universe. The universe has been around for an infinite number of years, but our little region of the universe was created at a specific time. So it's a sort of local Big Bang and there's some very weird, almost landscape of other universes. This is sometimes called the idea of a multiverse.
Which is terrifying, by the way.
I mean, it's already pretty big, right? So imagine even more of this stuff. I mean...
Is this... The multiverse is like where there's multiple fills? Is that an option too, where there's...
There are different... I get that. I think there's 4 different types of multiverse
right,
you could talk about.
Fuck it, let's hear them.
I'll try and remember them all. So the one I'm most fond of is this inflationary multiverse, which is essentially our region of the universe. We call it our Hubble volume. It's named after Edwin Hubble, who discovered that the universe was expanding. Is just one of many. And so we're essentially in one region of the universe that started off somewhere and then just expanded very, very rapidly in this thing that we now call the Big Bang. Traveling between those different universes would mean traveling very, very, very long distances, but it would be possible. It's also possible that going into another universe, another region, you'd find that the laws of physics would change slightly. So gravity would be stronger or weaker. Nuclear forces would be stronger or weaker. It would be easier to make molecules. It would be harder to make molecules. It turns out you need to really get the balance right on that stuff to be able to form stars, galaxies, and people. So if there are many universes out there in this type of multiverse, we're in a reasonably special one that allows us to exist. It's very easy for us not to exist if the laws of physics are slightly different. But there's other kind of multiverses too. There are some where they're literally other dimensions. So we've got our 4 dimensions, 3 space dimensions, 1 of time. Who's to say they aren't stacked up on each other in a 5th dimension, or a 6th, or a 12th, or a 20... So if you have something like string theory, that postulates that there have to be other dimensions. Some of them are too small for us to move in. So we can go up, down, left and right, but there's some other, A and B, that we can't move in because it's too small, and so we never notice it. It's a very hard thing to think of. But then there's others that they're large extra dimensions that you could in principle travel through if the laws of physics allowed you to. So in the same way we're sort of trapped on the surface of the Earth because we can't quite jump high enough to fly into space. I mean, we can with rockets, of course, but without a technology like that, we're sort of stuck on the surface of the Earth. You could imagine this type of multiverse being able to hop between different, they're called membranes or brains of the universe, being able to travel between them. Again, that's something where there's lots of theoretical models that you can come up with, and you can try and test their implications, but directly experiencing it yourself is probably never ever going to happen. There's another couple too. There's mathematical multiverses. All the stuff I keep saying mathematical model, right? That they feature a lot. We use maths as this fantastic tool to make definitive predictions of what happens. So we can say, oh, if this is traveling at this speed at this point, it'll be traveling at that speed at that other point. We can make predictions using these mathematical tools. This idea of a mathematical multiverse is maybe there are other universes that kind of exist where the rules of maths are different, and therefore the rules of physics will be different.
I know. Sir Roger Penrose is the guy that I listen to on this kind of topic, and he blows my mind. He's an excellent,
he blows my mind too.
He's excellent. He's been on some great podcasts. So again, another opportunity to learn. What's the biggest discovery or shocking discovery that you've made or learned in your career where it's really kind of like challenged you, or it's almost gone against the grain a little bit, gone against what you thought, and it's changed perhaps the direction that you've gone in, or just anything that's really stood out and you thought, wow, like, that's new, that's different, that's challenging? What would you say the biggest thing you've learned is?
So that's a really interesting question. Most of science isn't framed in terms of big discoveries, at least not when you're doing it. Of course, we remember most the people who make the big discoveries, but they're reasonably few and far between. The majority of the tens of thousands of scientists in the world aren't making groundbreaking discoveries even every year, 10 years, even maybe in their whole career. There's a lot of dirty work, really, of people just trying to measure a number better so it's more precise, so we can test a theory better. So for the vast majority of scientists, you never really have those big, I have discovered this thing moments. But as an astronomer, sometimes you find a new planet, or you find a new galaxy that looks weird, or something like that. I think
That's pretty big, Phil.
I mean, the people living in that galaxy.
I love it.
Think
Yeah,
so,
just found a new planet.
To me, it's a few pixels on an image.
Sure.
To them, it's almost their whole universe, right?
Yeah.
So,
yeah.
which is another weird trick of perspective that we have. But most of my aha moments have been more theoretical ones, where I've been trying to come up with ways of explaining certain things that happen in the universe, where there's a sort of mainstream explanation. So here I'm talking about dark energy. Our universe is expanding. We've known that for over a century, but the expansion seems to be getting faster. That shouldn't happen. Gravity always attracts. It should be making any expansion get slower, but for some reason it's speeding up. We've measured that. We've measured it to death, in fact, that speed up is happening. Why? What causes that? And there are various possibilities. One is called dark energy, where there's some relatively mysterious force that's pushing the universe to expand ever faster. It's kind of unsatisfying, though, as an idea in some ways, because we call it dark energy because you can't see it, you can't even feel it. All you can see is what it's doing to the whole universe. So maybe we've got that wrong. Maybe we should examine our assumptions and check to see if something somewhere is broken. So early in my career, I looked at one of these assumptions, which is that, particularly the question of, are we typical, or are we in a special place in the universe? And the conventional wisdom is we're reasonably typical. I think that's fair. Ever since Copernicus, we've sort of believed that the Earth isn't in the center of the solar system. The solar system isn't in the center of the galaxy. The galaxy isn't in the center of the universe. We're at that point where the prevailing wisdom is that we're typical. But what if, by some fluke or some other mechanism, we did live in a special location? What if we just happened to be here, and around us just happened to be, there's less stuff here, more stuff further out? What effect would that have on our interpretation of our observations? And it turns out if you did live in kind of essentially a big bubble in the universe, a big bubble, not like a soap bubble or anything. Imagine just there's less stuff here around us than there is typically in the rest of the universe. You can crunch the numbers, and that's what I did during my PhD, to figure out how that would affect things. And it turns out it gives you something that looks really like dark energy, just as a trick of the light almost. It makes the light as it's travelling to you not slow down or speed up, but be distorted in such a way that it makes you think the universe is expanding faster than it is. That'd be amazing, wouldn't it? So dark energy, we can rule out dark energy. I can go and collect my Nobel Prize. I've proved that we live in a bubble. It's not the way it works out. So my job there wasn't to come up with this idea, which other people had come up with too. It was to test it. And so I went out and tested that with data we had available. I didn't just measure how light travels. I looked at counting galaxies. Are there more galaxies here than over there? Are there there's certain blobs of ionized gas out in space that reflect stuff. I've called them space mirrors in the past, but that's a bit misleading. They're just reflecting some radiation, essentially. You can go measure those and see if that tells you something, sort of like looking around the corner with a mirror.
Right.
If it tells you something about whether you do live in a typical location or not.
What qualifies a galaxy?
A galaxy. So a galaxy is essentially any. So I should get to the punchline as well. By the way, we don't live in a bubble.
Good.
Just checking. Yeah. A galaxy is. It's actually quite a hard one to give a really rigorous description of, but it's a collection of stars, mostly stars. Big clouds of gas. We normally call them molecular clouds. That's sort of what stars are formed from. These clouds are just floating around in space. I say cloud of gas. There's barely any gas there. If you were in that cloud, it would be almost a perfect vacuum.
Right.
But they're gigantic. So there's a lot of gas.
Yeah.
It's just very diffuse. If you prod them in some way, maybe by a star nearby exploding, they collapse and form more stars, which is always very cool. And then there's other bits of shrapnel from stars that have formed and exploded in the past, dust, stuff like that, rocks, asteroids, comets, fragments of planets. We even see some planets that are traveling extremely fast because they've been thrown out of their solar system by a big explosion. Imagine living on that. But also dark matter. We know that in galaxies, the way they rotate is essentially much faster than you would expect if there was if it was just the stars and gas. Once you add the dark matter there, it explains why we see galaxies rotating the way they do. But again, that's another thing like dark energy, that it's a bit unsatisfying that we can't see it directly. We want to do more to try and detect it directly. We want to do more to try and make sure it's actually there, but we think we need it. So a galaxy is essentially a big jumble of all these components that's formed a gravitationally bound system. And what that means is, if you just leave it there forever, it'll just hang out. If it's not gravitationally bound and you leave it there forever, it will gradually fly apart.
Do you feel like everything's predetermined, even on a personal level? So what's already sticking in my mind is, at the start of this podcast, you were talking about how your dad, dragged you out of bed one evening and said, look at the sky. And I think you were 3 or 4 at the time, you said?
Yeah, they're pretty young.
Yeah, so again, out of your control, out of your influence. And that moment alone could have shaped your entire future of what you do, and, well, maybe it has.
It really could have done. It really could have done.
And do you think that one is true? Do you think that is all predetermined, and therefore free will may or may not exist? And do you feel like that carries on throughout the entire universe? Like, everything is going to be how it should. Everything is going to follow its path until the end, and that path is that's cemented. That's etched in stone. What do you think to the concept of free will?
So I honestly think it's not all set in stone. It really isn't. And part of the reason for that is, and again, forgive me for getting into the a bit more jargon perhaps, is quantum mechanics. So this is something we can literally test. So quantum mechanics is very weird.
I know, my little peanut brain and quantum mechanics, I haven't even dared go there yet.
But I mean, trying to sort of distill it to its essence, quantum mechanics is saying, like the normal physics we're used to in the everyday world. You're playing snooker, you hit the ball hits at a certain angle, therefore it must bounce back at a certain angle. That sort of physics doesn't apply to really, really small things like atoms. Everything's kind of fuzzy and uncertain, and if you think an atom is there at one point, there's only a probability that it's really there. Okay, so everything on those very small scales, that very small stuff, is uncertain, and we don't think, that's just because we don't know, we don't have a microscope powerful enough or something like that. That's something we've rigorously tested. That's fundamentally a property of the universe. So this table here, this feels very real and definite and solid to me, and I know if I turn around and then look back, it'll still be there. But on very, very small scales of atoms and molecules, everything's hazy and uncertain, and it's there one minute and gone the next. So because we know this is the way the world works, we rely on this. This is why semiconductors work. You need this for semiconductors to work. You need this for all sorts of like medical devices, drug delivery, stuff like that. Real practical things depend on quantum mechanics being a true description of the universe, so we know that's real. That tells us something about whether things are predetermined, whether there is, if you want to go as far as that, free will. And it's something we can test. So if you believe that the universe is what we call deterministic, B follows A always, then you can get into a position where you think, maybe there's no free will. That's sometimes called the clockwork universe, that a lot of scientists and philosophers a few hundred years ago were very keen on. It really fit into their idea of, God winding up the clockwork and letting everything play out. We know for the very small stuff, that's not the way the universe is. It's all random. It's probabilistic. It's, you know, our hypothetical billiard ball now doesn't necessarily have to go at exactly the angle we thought it would. We really rely on those quantum effects for a lot of the workings of modern technology as well. So we know it's real. But if everything is like hazy and undefined and probabilistic on those very small distances, what does that mean for big things like us? How can the small stuff be sort of random? It's not completely random. You can still, you know it'll go in that general direction. Your snooker ball, you know, it can't just go literally anywhere. But if the small stuff is not deterministic, why would the big stuff it's made up of be deterministic? And so that was a very long-winded way of me getting around to why I think free will is something that exists. Everything isn't predetermined. Lots and lots of sort of decisions or choices are being made in the here and now by subatomic particles. We're made up of those, so surely some of that randomness, some of that non-deterministicness applies to us too. And it could be going on in our brains and allowing us to make spontaneous decisions.
Do you live differently knowing what you know? Do you raise your son differently knowing what you know about the universe, about free will, determinism, expansion, curiosity? Do you factor it in when you're making big decisions?
It depends on differently from who, I suppose. So I'm not religious.
Mm-hmm.
I don't make decisions from a religious perspective. So, you know, the increasingly most people don't, but there are people out there who do make decisions because of some religious idea behind them. Do I gamble? I don't. So gambling is one of those things where if you have a handle on maths and probability, you know, eventually the dealer always wins.
Mm-hmm. Yep.
So that
Smart
puts
man.
me off a bit.
Yeah.
Is it? Maybe it's fun, but you know, that's another thing where I've sort of reasoned my way out of bothering with the national lottery.
Yeah.
Who knows? I could go and get a scratch card. Who knows? But on balance, I think because I know more than say your average about probabilities or stuff like that, that's a particular behaviour I don't do as much. Do I, knowing that we live in this vast universe that doesn't seem to care about us that much, do I plan for the future? Oh, absolutely. I because the thing that really matters to me is not, you know, what will happen to our solar system in 4.5 billion years. I won't be here. It's a really fascinating thought, but in the here and now, what matters is what's going on with my friends, my family, and stuff like that. So, yeah, I'm certainly still human. I want to be a human, do all the human things like, you know, keep up with the mortgage and stuff like that. It doesn't. I don't think. You know, for my colleagues as well, it doesn't take those things away. It's almost a separate part of your life in some ways, where you have modes. You think about normal day-to-day things for the most part, and then now and again you have a bit of time where you can think, is free will an illusion or something like that? It's an add-on rather than a fundamental part of me, I would say.
Yeah, no, that makes total sense. I think it's more the concept of time that would probably grasp my attention. You know, knowing time frames and how short that, you know, our existence is on this planet. I think in time scale frame, like it's a blade of grass on a football pitch or something, like one blade of grass. And that helps me make decisions. It helps me not to procrastinate, or at least to as much as it can. It has a positive influence, because I always feel the strongest goals they're backed up with a bit of fear. You know, something to move away from. So like, I don't want to get to the end of my life and waste it. So there's fear, good fear that can push me, and then having something to pursue. So that the purpose that we find in life. And I don't believe we're born with purpose. I believe that we create it. And I think that's an important part of any I'll say man because we're on the Better Man channel. I think that's an important part of any man's role, is to try and find and create purpose. And without that, I think that's when you start to question your existence a little bit more than you might if you got up every day and felt like you were contributing something to the world, or even to your people around you, your family. That's enough for most people, isn't it? Contributing to their family. I mean, imagine if every guy on the planet did that, just contributed to their family, that we'd live in a very different world. It starts with the small stuff. We started the podcast with this talk about the basics and the fundamentals. They're just vital to living a good life, I believe. One worthy of our existence, because, yeah, I don't think we should take that for granted. I think we should have to work hard to justify our being.
Well, you do make your own meaning. You do have to go out there and make your own life. And I think a really interesting thing about what you were just saying is, so much of that is defined in relation to others, and this comes back to what I was saying earlier about how in this universe everything's interconnected. We do matter on some level. You can't just, unless you put someone in a black hole, you can't be removed from the universe. Your actions do have an impact. You may or may not agree that they're significant, but they are. They're having an impact on other things, other people. They're part of the story of the universe. And so if you want to go out and grab there and make a bigger story, you've got to think about your relation to those other things, those other people. And really, I think that's where most of the meaning I derive comes from. It isn't me sort of sitting there having an idea about the universe, scribbling it down, and then folding my arms satisfied. That's part of it. The next part is telling people about it. It only really gains its full interest, its full excitement, its full power when I've not just written it down, I've shown someone else to share that excitement with me. And this is, I think, one of the best things about doing things like, we do open days with local school kids and stuff like that. Showing them Saturn for the first time is such a good feeling that, the feeling of me discovering something feels great. But, having a class of 10, 20, 30 kids, showing them Saturn for the first time, they're on a par, I've got to say. And that's great. I'm very privileged to have this job where I can kind of reliably go and, show an amazing, wonderful aspect of the universe to someone and know I'll get such a nice reaction. And yeah, I feel very grateful and privileged to have that opportunity to be able to show people how awesome the universe is, and how wild.
Well, it sounds like you're getting all your values ticked, But again, behind that, I'm sure has been a lot of hard work. It's, yes, gratitude, 1,000%, but I'm sure you've worked hard to put yourself in a position to achieve the fulfillment that you're experiencing. Because it would have been easy not to do that extra work and put in the hours and get the position. I'm sure you haven't just found yourself here.
Yeah.
So purpose is, you work hard for that, and then you get the reward in showing other people because you've spent the years dedicating yourself to learning. Yeah, there is a blueprint for me out there of how to live not a happy life, a fulfilling life, because they're very different.
They're different.
Oh, they're totally different. I'm a Jordan Peterson fan, and I'm totally on page with what he says about chasing happiness. It's not a great ambition in life, because shit's gonna happen, man.
But equally, that it's not that the corollary to that isn't that chasing suffering will get you where you want either, right? It's all about balance and thinking about the things that really matter or that you want to matter. It's
even balance. I'm not sure, is it? Like, if you find something you're all in on that's rewarding and you love, like, maybe you don't go balance, maybe you go all in.
I tell my students this every time they start their PhDs or something, and they're like, I'm dedicating my life to science. And 2 or 3 months in, some of them, they haven't slept and they're rubbish. They keep making mistakes.
That's probably not how I would.
So you've got to have some balance.
All in wouldn't mean at the sacrifice of your own personal health. But I just mean, when you discover what's really important in life. So it might be family, work, and having fun, like a hobby or whatever it is.
Yeah.
Like, for me, something we always look at is, okay, well, remove the stuff that doesn't serve you well and that distracts you from the things that you truly love. Because we are guilty of doing things that aren't good for us, and we know that. So it's like, imagine if I only did the things that were good for me and that I cared about. And there's a lot of satisfaction now. I think we get down and depressed a lot of the time because our attention is elsewhere. We're focused on external factors that are going on in the world, and understandably, it's easy to do that. But I think when you've discovered what you love doing, it's like, well, there you go. Dedicate your time and effort to that. When you're with your son, dedicate your time and effort to him. You know your role. You know what you're here for and what your duty is on that day or that specific hour. And when you don't have that, it's really painful. It's really painful when you don't know what you should be doing or what you're here for. But you have to work. It's
one of those things that as you do it more, as you get further with it, the motivation grows. More motivation itself. It becomes easier with time. It's like training a muscle, I suppose.
It's exactly like that. Motivation is a skill, for sure. Yeah, it comes after action. So the smarter you become, the more expert you become in your topic. Yeah, of course. You display more passion and motivation to know more.
And it opens up more options.
Absolutely.
It lets you operate on a different level than you were operating on before that, might get you closer to the thing you really care about. And for me, being able to go from, doing my A-levels in maths and physics where, we learnt just little bits of things to getting to a point where now I get to ask the questions I want to answer. It is, again, really... I could sit down and think, how did I get here? But, it's been 15, 20 odd years of studying a lot, I suppose.
Of course.
And gaining experience, learning skills, working with other people with new perspectives that I've benefited from. And I think that will be true of absolutely anyone, outside of science. Anyone who cares about what they're doing. I think that's where it all comes from.
Yeah, absolutely. The thing with motivation is it isn't rewarded straight away. So if you go to the gym for a week, you're not rewarded yet. You're rewarded after 8, 12 weeks of dedication. And then you look in the mirror and you're like, I'm changing, and boom, motivation.
If you can get to that point where you see, actually something was happening.
Sure.
And again, it's for you, it's the gym.
Yeah.
With my students, it's maths.
Yes, yeah, but I'm sure. But I guess it's the PhD that's your reward for these days where you don't feel like studying. You've got something to aim at, and the reward is waiting for you. If it's all in that daily process, right? This is what we're adamant on. So this is the crossover between, well, let's forget motivation for a minute. Let's talk about habits, routines, and disciplines. Like if you can get those, you're a dangerous person because there's very few people. Oh, that's an exaggeration. You're in the minority now if you're a disciplined person. You're in the minority.
It's hard to keep up that discipline with the amount of stuff that's going on around
that
isn't in your control.
It is. But it's hard not to be disciplined too, because you live a life that isn't necessarily anywhere near your best. So yes, discipline is hard. Of course it is. But I know that I was way more unhappy and depressed when I was ill-disciplined. That's for sure. So there's a payoff to both.
And once you've learned, once you've been there once, you do see actually, having that discipline hard at first, but then it brings its own rewards.
Absolutely, man. It's always hard. What's next for you?
What's next?
Yeah.
So really, I think it's what's next in terms of telescopes.
Okay.
So good, I get to talk about some serious hardware.
Okay.
So at the minute we're in the process of building this giant thing called the Square Kilometre Array. Its headquarters actually at Jodrell Bank up in Cheshire.
Yeah.
So I don't know if you've ever seen or visited that place, but it's super cool.
Okay.
It's this giant dish. They used it to track the booster rocket from Sputnik. It's got all this fabulous history. And we can use it to listen in on pulsars and black holes and all sorts of cool stuff. Now we're building this much bigger thing. It's split between South Africa and Australia. Both of them have deserts that are a really good place to build this because there aren't many people with mobile phones around. Mobile phones really get in the way of if you're trying to do radio astronomy. And essentially there's a big international collaboration where we're building hundreds and hundreds of radio dishes, connecting them all together and essentially using them all as, not quite a planet-sized radio telescope, but, a decent fraction of a planet. And there's all sorts of questions we want to answer with that. Things like what kind of molecules exist in the galaxy that might be useful for building life. Stuff about exoplanets, how do they form? One thing we can do is use the whole galaxy to detect gravitational waves. We can see how the whole galaxy ripples as gravitational waves from very early in the universe pass through it. That's a pretty cool one. Difficult, but pretty cool. So all of these things. And that's currently going into a construction phase. It's been 20 odd years of planning and designing and stuff like that. I'm after the next one now. And one of the ideas is to try and build not quite the same size, but similar idea of many smaller telescopes connected together on the far side of the moon.
Wow.
So that eyebrow raise there is exactly what I'm looking for. Because just as when people start talking about extraterrestrials and stuff like that, you might get an eyebrow raise or two. Yeah. Building stuff on the moon seems like a bit of a distant pipe dream, right? But it's becoming possible now. And it's always been possible, really, but it's becoming economical now. And so being able to have a telescope out there might be just what we need to see, not extraterrestrials themselves, but their airport radar.
Wow.
Airport radar is really bright. If they have airports and radar, we might be able to see it. But also, what I'm most motivated by is trying to map some of the first 100 millions of years of the universe's history. Very early on, there's lots of hydrogen gas around that emits a very weak, very feeble emission that we can detect with radio telescopes, and you can use it to build a 3D map of what the universe looked like back then. That's otherwise very hard to see. So, yeah, that's the thing. That's what I hope is next for me. Might take a few years or decades to get anywhere with it, but a map of the universe, that doesn't sound... Right. That's not too much to ask, is it?
No, I think it's probably the best answer I've ever heard, so that's cool. And I do have a traditional Better Man question to ask you.
Oh, great.
Which always gets people scratching their heads, and which is good. It's a sign of a good question. So, yeah, what do you, or what are you going to work on, or perhaps should you work on in order to become a better man yourself?
That is a really good question, and you know, I think with me, I recently had a son a couple of years ago. That's, you know, changes you a bit. Your priorities change. You know, I want what's best for him, but I think the thing, probably one of the things that's best for him is that I'm around for longer. That's in some ways that feels like a selfish thing to say, because I want to be around for longer to see him growing up, but also, you know, when I think of, you know, my own relatives, and I always wish they were around for longer, for example. And so one thing I think I really need to work on is just improving my health.
Cool.
In general. So I fell out of the habit of doing regular cardio during the pandemic, and it hasn't come back yet. So I think that I should take this conversation as an impetus to
well, I can nag you if you wish.
Get back out there. Yeah.
Well, if you need any help with that,
or disapproving looks will also work on me.
Yeah, I can send you the odd abusive text and say, Phil, what the fuck are you doing? Are you out there running?
Exactly. What are you? Yeah.
I can do that. Well, we've just spoke about the power of habit and routine and motivation, so it's a blueprint. I appreciate you coming in. I mean, thank you for being so cool today, and like I say, I felt like a bit of an idiot sometimes, just kind of like there's so much unknowns.
I thank you for the fantastic questions, and
it's been great.
You know, it's one of those things where, you know, if I could drag you into a lecture theatre for a few months and like show you all the amazing things, and we do some sums together, that I mean, I need to back away and realise people have their own lives, and perhaps don't want the military boot camp treatment. And
some will though. Like, what I love about this interview today is just you can still tell, like, you've still got that passion that I would expect someone who's just getting into the field to have. It's just brilliant. Like, you clearly want to share what you know. And the fact that you've come onto my podcast to talk about it all the way from London as well, which is amazing. It's
a
really
nice
great.
Train journey, though, I've got to say.
Yeah, sure, but it inspires me to keep doing what I do, because there are people that will listen to this and learn, and it's only through, you know, the art of us of communicating and making the effort to do this that I've become really happy because this is something I've always wanted to do. I've learned something today, and I get to pass on that knowledge like you do, and I get to say, right, people, listen to this. You might learn something new. So I appreciate it. Thanks so much for your time. It's been cool to meet you.
Likewise.
I know a cosmologist now. That's
yeah,
awesome.
thanks so much, and you're welcome anytime. We do. I mentioned we do open days. It's not just for school kids. Come see the big telescope.
I have got a bunch of guys as well. They would probably like to come as well inside of the group because they're all open to learning.
It's just cool stuff, and I've got to now. This is my job for you. You've got to go and see Saturn now. I promise you.
Yeah.
I promise you.
Yeah, for sure.
Doesn't have to be a fancy, expensive telescope.
No, okay.
Binoculars on a stand.
Maybe you can send me a little link.
Yeah, totally.
Just to something good enough.
And
that'd be cool.
You just somewhere that's a bit darker than under a street light.
Yes. Well, I'm lucky. I live in the countryside, so I get some nice
I'm very
stars.
Jealous.
Yeah. Well, yeah, London guy. Yeah. So I wouldn't mind sitting out there with a bottle of beer. I do. One of my very guilty sins, very guilty sins, is a nice cigarette once every 6 months. Look up at those stars. Yeah, if I can get those binoculars out.
Yeah, get a good clear night. There's a lot of them at the minute.
Yeah,
so no
that'd be good.
Yeah.
Cool. Thank you, my man. Appreciate your time.
No, great. Thanks very much for having me.
Thank you.
Lovely.
You were great.